This is a little video on arithmetic and geometric sequences. I had a student make a request to show how to solve problems number 21 on page 412 and problem number 25 on 416. So let's take a look at this. It says graph the arithmetic sequence in the coordinate plane. So they give a sequence 2, 3, 4, 5, 6. Now remember, this is a sequence. In the sequence, each of these numbers is considered a term. And this first term is considered a to the sub 1, right? The second term is a to the sub 2. See, that sub 2 tells you its location in the sequence, right? Because we could have, right, the sequence begins at 2. We could have another sequence that is similar, and you can see what separates them is 1, right? The thing that separates them is 1. But we could have another sequence that is almost just like this, but it goes like this: 10, 11, 12, 13, right? Where a sub 1 is going to be equal to 10 and a sub 2. So it's a different sequence. It behaves similarly, but it's a different sequence because it begins at it has a different beginning point. Okay, so let's, anyway, so, and then we'll have, okay, we'll go, the third term is a sub 3, we'll go down like this: a sub 4 and a sub 5, that's a sub. And now we don't know what the rest of these are. So this is a sub n, because remember, this is algebra. So we're called an n because it's an unknown. It's a variable. We don't know what this term is out here, right? Okay, so it says, so now we kind of have an understanding of these. So we're dealing with a couple different things. We're dealing with a sub n, and then some other thing that, and then the actual variable itself is n. And what we need to do is, well, you need to graph it on a coordinate plane. So the nice thing is you only have to find two numbers. Well, we have one of them right here, and actually in reality we've just identified the second one right there. So let's start tables are always the easiest way to go when having to do a coordinate plane. So, and then the n is the x, what would be considered the x-axis, and a to the n is the y, what would be considered the y-axis. So look at this. Here we go. Right here. Here's a 1. It is when n is 1, right? When n is 1, a to the n is 2, or a to the a to the first, right? A to the first is 2. When n is 2, right? A to the 2 is equal to 3. See how that pattern is going? We'll have, and then the third term, what's the third term? The third term is just 4, and the fourth term is just 5, and the fifth term is just 6. Because a to the 5, or the fifth term, is 6. So now we have that. It's pretty straightforward. 1, 2, 3, 4, 5, 6, right? So when n is 1, a to the n is 2. That's right there. When n is 2, here it is here, a to the n is 3. When n is 3, a to the n is 4. And you can see the pattern. My gosh, at this point you don't even have to think. It just goes up and up and up from there, right? Okay, that's how this one works. Let's take a look. This is the how they show the answer in the solution guide. Oh yeah, and it's the ordered pair of n, comma a to the n. Okay, let's take a look at the next one. And basically you don't even have to know that. The interesting thing about graphing these is you don't even have to know what is the multiplier here. You don't have to know how to compute that, because that's not what it's really asking you to do. All it's asking you to do is identify the n and a to the n. Just define the terms. Just define the terms, right? So we know that a to the 1, right? A to the 1 equals 3. Oh, the first term. The second term is a to the a sub 2, right? That's the second term equals, oops, that's negative 1. Negative 3, negative 1. And the second term, the third term, the third term is equal to negative 1/3, right? So it looks like, what's making this work is it's all being multiplied by 1/3, because that's the difference. That's the multiplier for each one of these is 1/3. So here we go. Here we say that when n is equal to 1, a to the n is equal to negative 3. When n is equal to 2, right here, a to the n is equal to negative 1. When n is equal to 3, a to the n is equal to negative 1/3. When n is equal to 4, a to the n is equal to negative 1/9. When and here we have here, right, this is a to the 5th. When n is equal to 5, you see, because there's the 5 right there. A to the n, or basically the 5th term. What is the 5th term? It's negative 1/27. Okay, and then you just graph that. 1, 2, 3, 4, 5, 6. So when n is 1, a to the n is negative 3, negative 1, negative 2, 3 right there. When n is 2, a to the n is negative 1. When n is 3, a to the n is negative 1/3, about right there. 1/9, look at that, is getting closer and closer to the x-axis or the nth axis, but it'll never touch it. There's the asymptotic line right there. Okay, let's take a look, and this is the way they show it in the book. Okay, hopefully you found this to be helpful.